Welcome back. This is the last video of the wave interference exercise, and all we gotta do in this video is just take our results, which we derived in the past few videos, and the result is right here. All we gotta do is just take this result, voila, the lines of destructive interference. We gotta take this result and plug it into the editor. So before I go and do that, I want to just talk about why we went through all of that algebra and geometry. So right here, our goal is to, if you look real closely, this line right there, this is the lines of destructive interference. Our goal is to get a line that maps that goes along that destructive interference. And so these past couple of videos, that was our goal. We went through all the algebra and geometry to get that particular line. So as I said, this was the result. Let me talk about the result before I go to the editor. So we have our big thing. We got the y plus or minus, and then we got our 4d. We're going to talk about that d in our editor in a little while. And we got our n and lambda. So keep that in your mind. I'm about to jump to the code, okay? So let's jump to the code and let's see how this will play out. Okay, so as always, just click here, and then when you get to the editor, just kind of clear that out the way. Have a lot more space. So let's just start off just seeing the exercise. So this is just right there. That's just a regular line. That's y equal x. That's nothing special. As you can see, it's not matching up with our. I get out the way with our with the destructive interference. So as I said before, our goal was to match that particular line right there, okay? So let's get that, because we did it, and now let's reward ourselves. So let's pause this. Let's get some more working space. And before we jump and just start putting things in the editor, let's talk about some of the variables. We got our position of the speakers, position of their mic, and we got our sound, our speed of sound right there. And we got our lambda, okay? So really just that lambda we're going to use a little bit in this video. So before we start putting things into the editor, let's talk about the D. As I said earlier, that D is the distance between our speakers, right? It's our distance between our speakers, but half that distance. Not the total distance, but half the distance between our speakers, okay? So let's put into our editor our result from earlier, okay? So we had 4 times d divided by lambda, and this is one of the hardest parts of this video, honestly, because spelling lambda is embarrassing. Okay, I'm about to mess this up, but voila, okay. Yeah, it's very hard. There's lambda right there, okay? So remember, in our result, it was y plus or minus. It wasn't just our positive y, it was our minus y too. So let's jump down here. Remember, we gotta uncomment this, so let's just backspace that star and that slash, and do the other one as well. And voila, okay? So just go right here, our m, and do the same thing as 4 times d. It's minus 4 times d divided by lambda. Voila. So play it, and look at that. Look at that right there. You see how that line is perfect? It's just right exactly on the red line right there. It's right on top of the destructive interference, and that was our goal. After all the algebra, all the math, we did it. It was hard, but it was worth it, because I am very, very happy about that. And so if we move the mic right there on top of the line, all the sound go to 0, and it's awesome. I don't know about you, but I'm pretty happy about that. It was a lot of work, but if you want to keep playing around with this, you can use touchscreen if you have a touchscreen device. You can move it over, and even if we move it over, the result is still the same. We can put the mic right there, and voila. So we did a great job. I'm proud of us. I'm proud. So, but maybe, just maybe, we probably got lucky. So let's tweak it a little bit just to have a little fun. Nothing too dramatic. So let's pause it. Let's see the code a little bit more. Scroll up. Let's change the lambda to I don't know, 50 will be fine. So let's move this back over because we don't need the code no more. Let's play it. So instantly you will see that the wavelengths are a little bit shorter, but no matter what, the lines that we got are still right on top of the destructive interference. Let's see if I can zoom this in just a little bit more. Hopefully you can see that a little bit more. We can't see the speakers, but right there, that was our goal. I cannot do it, but the math can, okay? So thank you, math. So let's play around with the speakers a little bit. And even as we do that, we still, the lines still match perfectly. So it was really fun to play around with these, honestly. I like it. So anyway, let's pause it. And remember that the n was n equal 1, 3, 5, on and on and on and on. We're not going to go on and on and on. But let's see what happened if we change n equal to 3. Right now it's n equal to 1. So before I do that, let's change this to 86. Oh, wow. There we go. Let's change that to 86. And let's change it to n equal to 3. So when you do this, remember you gotta, let's do it with parentheses. So it's 3 times lambda, and it's 3 times lambda. Okay, so there we go. Let's close this over. Let's play it. So let me zoom in just a little bit, see if we can get a better up close onto that. So before, we were trying to match these lines, okay? Right there. And that line right there is when n is equal to 1, right? And that line over there is when n equal to 1 as well. But now we're trying to match these lines. And that's when it's equal to n equal to 3. Okay, and the corresponding n equal to 3 is right there. Okay? Now, as you can see, it's not as perfect as when n equals to 1. When we derived our result, we assumed that y was much, much greater than x. So we assumed that the lines would be like this, very, very steep. And this is only true when n is equal to 1. However, when n is equal to 3 or to 5, the lines will be like this, a little bit more shallow. However, we assume that it would be like this. So when n is equal to 3 or to 5, our assumption that y was much, much greater than x is no longer true. So to recap, we assume that the lines are going to be like this. But when we change it to 3 or 5, the lines will be like this, and our assumption is invalid.